Okay, we're going to examine the operation of an ordinary 12 volt 30 amp automotive relay. In this case it's a 5-pin relay. So you can see there it's just a common or garden relay. So if we take a look inside the relay, we can see that it simply consists of a coil of wire and basically a set of contacts. So you can see the contacts there. So coil of wire, set of contacts. So now we're going to draw a diagram of what's actually going on in there. So there's a soft iron core at the center of the relay. And the reason why it's soft iron is because soft iron is very easy to magnetize, and then once you stop magnetizing it, it stops being a magnet. And how we actually magnetize it is we simply wrap a coil of wire around the soft iron. Now there's no electrical contact whatsoever between the coil of wire and the soft iron. And we run that coil of wire to chassis. Now, when we pass electricity through that coil of wire, one of the three effects of electricity is magnetism. So a magnetic field is set up around that coil of wire. The magnetic field is concentrated into the soft iron, turning it into an electromagnet. So, directly above the soft iron are a set of contact points. And obviously, when the soft iron becomes a magnet, it attracts the contact points to become closed. But now we have a 5-pin relay, so there's another set of contacts just above. And they go off. So now let's look at terminal designation. So the live supply into the contact points is from the battery, so that's terminal 30. We're going with DIN codes here. And you can see there's a set of contacts that are open. So they're known as the NO contacts, the normally open contacts. So we're just going to mark them. And the bottom line there goes off to terminal 87, which is off to your load. So whatever load that this relay is servicing, that's the connection there. The top set of contacts are normally closed, NC. And they have a designation of terminal 87A. Okay, now, next thing is we're going to look at the operation of the coil. And there's a common misconception out there that 85 is the start of the coil and 86 is the end of the coil. This is not the case. The DIN codes are 86 is the start of the coil and 85 is the end of the coil. Now, people will say that the relay will work exactly the same either way, and that's true. But unless we wire it the correct way, we're going to give ourselves big problems, and we're going to examine why now. So we're going to take our 5-pin relay and we've put it into a tester here. So we have a little test rig made up, and as you can see there, when we put it in there, the red light comes on. That's indicating that terminal 87A, the NC contacts normally closed, are live the whole time. So now we push the button and energize the coil. You can see that 87 becomes live. So that's the NO contacts, the normally open contacts. So we're just going to operate there a few times. And if we look closely there, we can see the contacts actually going opened and closed. So that's the operation of the relay. That's a 5-pin relay. Now we're going to go and see what's happening now electrically with this. So in order to do this, we set up a couple of relays. So here you can see it's just another 5-pin 30 amp relay, and we have it across a 13 volt supply, so roughly equating to vehicle system voltage. And we have this connected to a 2-channel PicoScope. Now, because we don't know exactly what way this is going to affect us, maximum voltage for this instrument here is 20 volts. So what we have is we're putting our supplies in, or our test leads in through 20:1 attenuator. So in other words, they're reducing the inputs by a factor of 20. So we're protecting the instrument. So that's on the A channel. We have this relay, and we have a second relay on the B channel. We'll discuss that in a moment. So we're going to look at what's happening now on the A channel when we open and close the contacts on the relay. So just run over there again and again. So there we can see that when we actually operate the relay, that when we open the contacts on the relay, we get a hell of a voltage spike. So we're going to actually measure that voltage spike now by using the scope. So we're going to bring down measuring lines there, and we're going to bring the first one down to roughly 0, and then we're going to bring the second line down to roughly the maximum there, just somewhere in there. And we can see there we're getting about 11.5 volts. Let's call it 11 volts. Right? So we know that we're going in through an attenuator. So what we're actually reading there is a voltage spike of approximately 220 volts. Now obviously, a voltage spike like that, if there's any electronics downstream of this relay, they're going to be damaged. So we can't allow this voltage spike to get into the system. So we have to eliminate the spike. So what we've done is, you have exactly the same 5-pin 30 amp relay, but this time you'll notice that we have a diode across the 86-85 terminals. And you'll notice that the diode, the cathode, is pointing back towards the live. And what this diode does is that it reduces or eliminates this spark when you open the circuit on the relay. So now we're going to go back to the scope and we're going to switch on the second channel. So we've got 2 channels switched on now. The blue is the one without the diode, and the red is the one with the diode, and we're going to switch them again and we're going to see what happens. Now again. Oh, there we are, we got it. Okay. Now, so now you can see the blue, you still have the spike, and you can see there in the red channel with the diode across it, and clearly you can see no spike. Let me just do it once more there, we'll have a look. And there we can see it there, and a bit more of a spike this time, but it's massively reduced. So you can see there a massively reduced spike. So that's the reason why we need to always connect relays in accordance with the DIN codes. In other words, 86 is the start of the winding, 85 is the end of the winding. Because if there is a diode wired into the relay to prevent spiking, if you do it the other way around, the diode is pointing the wrong way and it's not preventing the spike, and the spike will damage any electronics in the system. Now that's why it's absolutely essential when wiring the relay to wire it terminal 86 start of winding, terminal 85 end of winding.